Imagine a world where coastal cities are fortified against rising seas, buildings generate their own energy, and roads repair themselves in extreme weather. This is not science fiction. It's the future of engineering in a world facing climate change. As our planet warms, we face a growing number of challenges, from rising sea levels to more frequent and intense storms, heat waves, and droughts. But with every challenge comes an opportunity for innovation. Engineers across the globe are pushing boundaries, designing solutions that could not only mitigate the effects of climate change, but help build a more sustainable future. Today, we'll explore how the world's brightest minds are addressing these issues with cutting-edge technologies. From climate-resilient infrastructure to revolutionary materials, you'll see how the engineering field is evolving to tackle the climate crisis head-on. Let's take a look at some of the most exciting engineering breakthroughs happening right now. Coastal cities are on the front lines of rising sea levels, and innovative coastal defenses are being designed to protect urban populations from flooding and erosion. Engineers are building sophisticated seawalls, levees, and flood barriers, but they are also thinking beyond traditional methods with groundbreaking ideas like floating cities. In places like the Netherlands, floating neighborhoods are being designed with adaptable housing that rises and falls with water levels, preventing damage from floods. One example is the Thames Barrier in London, a marvel of engineering that can be raised to block high tides, protecting millions of people from flooding. Venice's MOSE project is another example. Movable floodgates that protect the historic city from the rising waters of the Adriatic Sea. Looking to the future, floating infrastructure and amphibious architecture might become more common, allowing coastal cities to expand even in the face of rising oceans. These developments demonstrate the innovative ways engineers are confronting the reality of climate change, turning threats into opportunities for new urban designs. One of the most pressing issues in a warming world is water security. As global temperatures rise, droughts are becoming more frequent and severe, threatening water supplies for millions of people. But engineers are developing groundbreaking solutions to ensure a sustainable water future. Traditionally, desalination, removing salt from seawater, has been an energy-intensive process. But engineers are now harnessing the power of the sun to make desalination both sustainable and affordable. Solar-powered desalination plants are being deployed in regions like the Middle East and parts of Africa, where fresh water is scarce but sunlight is abundant. These plants use solar energy to power the desalination process, reducing the need for fossil fuels and making water more accessible to drought-stricken communities. This technology has the potential to transform coastal areas by providing fresh water at a fraction of the environmental cost compared to traditional methods. As the global population grows and freshwater resources become more strained, solar-powered desalination could be a game changer in ensuring that communities have access to life-sustaining water. In regions where rain is rare but fog is frequent, engineers are turning to an ancient but effective solution: fog harvesting. Using large nets placed in foggy areas, water droplets are captured from the air and funneled into reservoirs. These simple yet ingenious devices can capture thousands of liters of water per day, providing a vital source of water for agriculture and drinking in areas that face chronic drought. Countries like Chile and Morocco have already seen success with fog nets, where they are used to supply water to rural communities. This low-tech solution has enormous potential for scalability, especially in regions where other water-gathering technologies may not be viable due to cost or geography. Engineers are also working on ways to store and manage water underground, in a process known as aquifer recharge. By capturing rainwater and excess runoff during wet seasons and channeling it underground, water can be stored naturally in aquifers for use during dry periods. This method not only prevents evaporation, which is a major issue with above-ground reservoirs, but also helps stabilize water supplies in regions with highly variable rainfall. In places like California and parts of India, aquifer recharge projects are providing a buffer against droughts, ensuring that communities have a steady supply of water even during long dry spells. This technique is especially important as climate change leads to more unpredictable weather patterns, with long periods of drought punctuated by brief, intense storms. In a warming world, the availability of fresh water is becoming one of the most critical issues we face. But thanks to innovative engineering solutions like solar-powered desalination, fog nets, and aquifer recharge, we have the tools to adapt to these challenges. By rethinking how we gather, store, and use water, engineers are ensuring that future generations will have access to this most essential resource, no matter how the climate changes. Now, let's really geek out and dive into one of the most cutting-edge innovations that's revolutionizing how we think about carbon capture: metal organic frameworks. Metal organic frameworks are highly porous materials that act like molecular sponges. Each gram of MOF material has the surface area of a football field, allowing it to capture enormous amounts of carbon dioxide. The exciting part is that these materials can be fine-tuned at the molecular level to become even more efficient, potentially revolutionizing carbon capture on a global scale. Imagine an industrial plant, or even a building covered in MOF panels that are continuously pulling carbon from the atmosphere and storing it safely. And when it comes to construction, one of the most exciting innovations is carbon-negative concrete. Traditional concrete is responsible for about 8% of global carbon dioxide emissions, but new processes are being developed to actually absorb carbon during production. This is done by incorporating industrial waste products like fly ash, and even using carbon dioxide from the air during the curing process. Engineers are essentially reversing the environmental impact of concrete, which is a game changer for the construction industry. Carbon-negative concrete could be used in the construction of everything from high-rise buildings to bridges, drastically reducing emissions from one of the world's most essential materials. If scaled up, these innovations could significantly lower the carbon footprint of the construction sector. Here's where things get truly exciting. These engineering solutions aren't just about survival, they're about building a better world. Imagine cities where infrastructure is designed to work with the environment, where our homes generate their own energy, and where carbon is removed from the atmosphere as we go about our daily lives. This is the engineering future we're working towards. And while the challenges are immense, so is the potential for innovation. The work happening today in labs, design studios, and construction sites across the world could redefine how we live in a warming world. As we've seen, the future of engineering is one of adaptation, resilience, and sustainability. From climate-resistant cities to renewable energy breakthroughs and revolutionary materials, the innovations being developed today could safeguard humanity in the face of climate change. But we must act now to support these developments, fund climate research, and implement these solutions globally. If this video inspired you, make sure to like and subscribe to Global Prospects for more deep dives into the technologies shaping our future. Share this video with your friends to spread the word about the incredible potential of engineering to tackle climate change. Let's keep the conversation going in the comments. What do you think is the most important engineering breakthrough for fighting climate change? And what are you most excited to see in the future? Thanks for watching, and remember, our future is in our hands. See you next time.